If you've ever been part of a big software project, you know the feeling, right? The code says one thing, but the user manual, well, it says something completely different. Today, we're going to dive into a framework called Drasil that's trying to solve this exact problem for good by making sure everything, and I mean everything, is generated from a single perfect source of truth. So let's start with a really fundamental question. When you're building a piece of software, where does all the knowledge about what it does and how it works, where does it actually live? Is it buried in the code? Is it in those design documents? The user manual, maybe? Well, the messy reality is it's usually scattered across all of them. And this, right here, leads to a huge problem. You've got the code, which is the logic that's actually running the show. And then you have the documentation, which is supposed to explain that logic. But what happens when a developer updates the code and, forgets to update the manual? You get a conflict. The two just drift apart over time, and suddenly, nobody has the complete, correct picture anymore. It is a total maintenance nightmare. And look, this isn't just some minor inconvenience. It's a fundamental flaw that's kind of baked into how we've always built software. This is what the folks behind the Drasil project call software's duplication problem. Just think about it for a second. That same little piece of information, it could be a physics formula, a business rule, a specific calculation. It has to be written down over and over and over again. It pops up in the code, then it's described in the specification document, it's used to write the tests, and of course, it's explained in the user guide. And every single time you write it down, you're rolling the dice, risking a tiny error or an inconsistency.
So if duplication is the enemy, what's the solution? Well, the philosophy behind Drasil is actually elegantly simple. Just stop duplicating knowledge. Instead, create one single source of truth for everything.
This brings us to the absolute core insight of the Drasil project. It argues that all those different things, the code, the docs, the tests, they aren't really separate things at all. They're just different views of the exact same underlying knowledge. And realizing this, well, that's the big aha moment. Here's a perfect example of what we mean by views. In a document, you'd write out the classic physics equation, F equals ma. We all know that one. But in Python code, that exact same knowledge is expressed as force equals mass times acceleration. The way it's represented is different, sure, but the core concept, the truth, is identical. They're just two views of one central idea. And the payoff for this approach, it's this incredible thing called perfect traceability. Since everything is generated from that one source, you can be absolutely certain that what the manual describes perfectly matches what the code actually does. They aren't just checked for consistency. They are coherent by their very construction. It's literally impossible for them to be out of sync. Okay, so that's the big idea, right? The philosophy. But how does this actually work in practice? Let's take a look at the process Drasil uses to literally forge software from this single source of truth. The workflow is actually beautifully simple. First, you define all of your domain knowledge, all the equations, definitions, constraints, in a central knowledge base. You only have to do this once. Then you run the Drasil framework, which basically acts like a powerful generator. And finally, boom, Drasil spits out all the artifacts you could possibly need. The source code in a language like Python, the formal spec documents, the test suites, you name it. And all of it is perfectly automatically in sync. And this isn't just some academic theory, This isn't just a cool idea on a whiteboard. Drasil is already being applied to solve some pretty complex, real-world engineering and scientific challenges.
I mean, the range of applications here is pretty impressive. Drasil can generate the software to simulate a solar water heating system, or build a physics engine for a video game, or analyze slope stability for civil engineers. The common thread is that these are all what you'd call well-understood domains, where the core scientific principles are stable and already established.
So what's the ultimate goal here? The real payoff of this entire approach is to build software that is coherent, not by chance, not because a team was really careful, but by its very design. Drasil is built on a few really smart principles. First, the core knowledge in fields like physics or engineering, it doesn't change very often. F equals ma is still F equals ma, right? Second, software in these fields can be put together from this stable knowledge. Drasil also recognizes that documenting why a design decision was made is just as critical as the code itself. And most importantly, it's designed for software that has to last for a long, long time. And when we say a long time, we're not exaggerating. The source material points out that a lot of this critical scientific and engineering software can be in use for 10, 20, even 40 years. Can you imagine trying to maintain a 40-year-old code base where the documentation and the code haven't agreed for decades, an approach like Drasil becomes absolutely essential for that kind of longevity. Ultimately, Drasil's mission is to transform software development into a true engineering discipline. Think about it like an architect's blueprint for a skyscraper. It's that single, authoritative plan that the electricians, the plumbers, and the builders all work from to make sure they're building the same thing. Drasil wants to be that blueprint for software. And this leaves us with a really fascinating final thought. As our world relies more and more on complex software for our critical infrastructure, for science, for engineering, an approach that guarantees coherence and traceability isn't just a nice-to-have, it might just be a necessity. So the real question is this how we should be engineering our digital future?